Hey guys, so this week we're going to start getting into exponential functions and logarithms. And so we're going to get into more the algebraic side as opposed to the graphical side, which we did last week. So before we get right into rational and integer exponents, I thought I would just go over some of those exponent rules that you should already know, but if you don't know, I'm going to go over them. So here we go. The multiplication rule says that if we have a base with an exponent multiplied by the same base with a different exponent, all we're going to do is add the exponents. So the key note here is that they are the same base. Notice how those are the same. Otherwise, it doesn't work. So make sure they're the same. I'll show you an example. Let's say we had 2 to the 3 times 2 to the 4. All you're going to do is add the 3 and the 4, and it becomes 2 to the 7. So then we move over to the division rule, which looks like this. If we divide it, again, we want to make sure that we have the same base. What you're actually going to do is subtract. So it becomes n minus m. So we'll subtract. The exponents. I should have said over here that we're going to multiply. Oh, not multiply. We're going to add them. Add the exponents. So over here we subtracted them. I'll give you an example. So for this example, I'm just going to do 6 to the 11 divided by 6 to the 5. So you can write it either way with this division sign, or it looks like this, and that line also means divide, in case you had forgotten that. So this then becomes 6 to the 11 minus 5, which is 6 to the 6. Now the power of a power rule simply states that if you have a power or an exponent and then another exponent, all you're going to do is multiply. Multiply the exponents. And I'm going to show you two different examples because I want you to see what happens when we have a number in front of there. So let's say we have a to the 3 to the 2. All you're going to do is 3 times 2, which equals a to the 6. Now, one of the extensions of this is, let's say we have a value in front of there. So instead we have 2a to the 3 squared. Now, when you have something like this, you want to be careful because it's in brackets that exponent is applied to both values. So it actually becomes 2 to the 2, a 3 times 2. And you're going to actually evaluate that 2 to the 2, so it becomes 4 a to the 6. Okay, so watch out for that, especially if you have a number in front there. That exponent on the outside has to be applied to that as well. Now, this is probably my favorite rule, but I don't know why people mess it up all the time. But whenever you have an exponent of 0, the answer is just simply 1. Okay, it's not 0. Please don't make that mistake. It is always 1. So for example, let's say we had 3 to the 0. The answer for that would be 1. 17 to the exponent of 0. Answer is 1. Even if we had x to the 0, the answer will be 1. Don't forget it. 0 exponent, answer is 1. Negative exponents might seem a little bit newer, or you may not have as much practice with it. But I'm going to show you a couple things with their negative exponents. So first of all, if we have a negative exponent, the one thing you're going to do is you're going to take that base and you're going to turn it into a fraction. And I'll show you a fraction. So it will actually become 1 over a. So it becomes a fraction of 1 over that base, and then the exponent becomes positive. So the exponent becomes positive. Okay, now this looks better when you do an actual example, so let's do one. Let's say we have 3 to the negative 2. You're going to make that 3 into a fraction of 1 over, so it becomes 1 over 3, and then the exponent becomes a positive 2. And if you want to evaluate it, you're just going to do 3 squared, or 3 to the 2, which is 3 times 3, or 9. So your answer would just be 1 over 9. Really simple when you get that. Get into the habit of putting it into a fraction and then changing it to a positive. Now, one of the questions sometimes I have, or that you will see, is let's say that you have an exponent or a fraction, and then your exponent is negative. Let's say, what am I going to do with that? The quick way to do that, I'm just going to move it over a bit, is you actually will flip the fraction. So it becomes 3 over 2, and then the exponent itself becomes positive. So you're going to flip the fraction in this case. Now the other thing, and then the exponent becomes positive. If you wanted to solve this, make sure that 2, just like in the previous example, gets applied to both the numbers, the number on the top and the bottom. So it becomes 3 to the 2 over 2 to the 2. And if we actually evaluate that, 3 to the 2 is 9, and 2 to the 2 is 4. So we get the fraction 9 over 4. Okay, and that's pretty much all there is about what to do with negative exponents. I'm just going to go down and we're going to do our rational exponents. So rational exponents, this is probably the one that is new to you. And when I say rational, what I'm really saying is that they are fractions. So if you didn't like fractions, you might not like them even more. But basically, we can have exponents that are fractions, and I'm kind of going to show you how to deal with that. So let's say we have a and their fraction is n to the m. So what happens is this m actually becomes the square root. So it becomes the root, and you're going to do it m times, and then that becomes a to the n. You can also write it, and I'll show you in an example, is you can write it like this. Both of these are equivalent. They equal the same thing if you actually go to calculate it, but I'm going to show you some examples so you can actually see just what I mean by this rule. Okay, so let's say that we had a to the 3 over 2. So the 2 means that you're going to take the root 2 of a, and then you're going to cube a. Okay, if you write it again, you can write it like this. it equals the same thing. Let's put some numbers in there and see how we can actually apply it with values. So let's say we had 2 to the 3 halves. So with this one, it's going to become 2 over 2 to the 3. So you can calculate this 2 different ways. I'm going to show you each way. So the one way is to do the root first. So in this case, we're going to find the root of 2 first. So we're basically going to do this part first, and then we'll do the cube after. So if you find the square root of 2, and I'm going to do it on my calculator, I get 1.4142 to the 3. And then if I actually cube that, I get an answer of 2.8284. So that is the first way to do it. You can take the square root and then cube it. The other way you can do it is we can do the cube first. So you can do that top number first. So you can actually do it like this. So in this case, we're going to find out what is 2 cubed worth. So 2 times 2 times 2 is 8. And then we'll take the square root of that. So if we take the square root of 8, you'll find you get the same answer. So it really doesn't matter which way you do it. I made a mistake there when I did it. That's a 4. But you notice that you get the same answer here as you did here. So it doesn't really matter which way you do it first. You can do the bottom number and take the square root or the cube root or fourth root of it first, and then do the exponent, or you can do it the other way around. So you should get the same answer. But anyways, those are kind of a review of the rules, plus the 2 new ones, your integers, and especially those rational ones. Those are brand new. Try some of the practice questions, and then there's a quiz to do. I think I've also posted some extra videos if you want to check them out as well. Okay, bye.